Hello, ladies and gentlemen. Today we're going to be going over how to simplify radicals using what I'm calling the perfect square method. So the perfect square method, you have to know your list of perfect squares. So your perfect squares are 4, 9, 16, 25, 36, 49, so on and so forth through your various numbers. I'm going to write up to 100. Okay. And they keep going. And the way I get my perfect squares is I do 2 times 2 is 4. 4 is a perfect square. 9 times 9 is, 3 times 3 is 9. 9 is a perfect square. 4 times 4 is 16. 16 is a perfect square, so on and so forth. So when I use the perfect square method, what I'm looking for is a number, a perfect square number that will divide into what I have here. And so what I can do is rewrite 245 as 49 times 5. So I can take the square root of 49, which is 7, and I'm left over with the square root of 5. And that's my answer. But I have to break down 245 into 49 times 5 before I can take the square root of 49. So that's how you do that. It's a little bit simpler than the factor cake method if you watch that video. However, it is a little bit more trying on the brain and a little bit more guessing and checking. So, and with larger numbers like 245, it can be a little complicated. So with number 4, 32 is a little bit easier. So 32, when I think of 32, I know 4 goes into it 8 times, but I also know 4 goes into 8, so 16 will work as well. So 32 divided by 16 is going to be 2. So I can rewrite 32 as 16 times 2. And I can rewrite the square root of 16 as just 4, and then square root 2. So the square root of 16 is 4, and then I keep the square root of 2. For number 6, 200 can be broken down into 100 times 2. So the square root of 100 is 10, and I'm left over with the square root of 2. So this method can be faster, but it can also be a little bit more complicated. Like with number 8, 320. I'm not exactly sure off the top of my head what goes into it. I just did 16, and I got 20. So I could do 16 times 20. The square root of 16 is 4, but 20 I can break down into 4 times 5. So I can keep the 4, take the square root of 4, which is 2, and keep the 5. So 4 times 2 is 8, and I get 8 square root of 5. So sometimes I take it step by step and make the number smaller so it's easier to work with, and then do the same process again. So, that's another thing you can do with those larger numbers. And then looking at my answer, I know 64 would have worked at the beginning because 8 times 8 is 64. If I put that 8 back in the square root, it would have been 64 in the square root. So there's that. So when we're dealing with variables, I kind of do a similar thing. So let me see, 72, I think it's 36. Yes, it is. So 72 can be written as 36 times 2. And p to the third, we want to break up. We want to take a single p off of it. So we have p to the second times p. Okay? So I can take the square root of 36 and p to the second. The square root of 36 is 6. The square root of p to the second is just p. And then I'm left over with 2p underneath. And that's my answer. So for number 14, when you have even an even exponent, all you do is you divide by what the what's called the index. This number that's not here is a 2. We divide 4 by 2, and that's how we get rid of the variables, and I'll talk about that more in a minute. So with 28, we can write that as 4 times 7. And we're going to leave x to the fourth because we just want it to be even. Since it's already even, we're not going to mess with it. The square root of 4 is 2. So I'm taking the square root of these two. And the square root of x to the fourth is x to the second. So you just do 4 divided by 2. and you just write that for the exponent. And then you're left over with 7, and that's it. So, last one here that I'm going to do. So we've got the square root of 27 can be written as 9 times 3. Then we have m, and then n to the third can be written as n to the second times n. So I can take the square root of 9 and n to the second. So the square root of 9 is 3. The square root of n to the second is n. And everything else that I didn't circle stays underneath my radical. And that's going to be it. I hope you found this informative. If you have any questions, please let me know. And I hope you have a great day. Bye-bye.